we have this statement that we must prove by mathematical induction. It says the sum from r equals 1 to n of 3r minus 2 is equal to 3n minus 1 over 2. I want you to pause the video, write this down on paper, go ahead and solve it, or to prove it I should say. Okay, are you finished? Let us look at it. So here, remember the first step you should take, step 1. Alright, let me not bother to write step 1. Let me just write this step. Show that P1 is true. The statement involving the number 1, r equals 1. That's where you start off. So therefore, n is also 1 when r equals 1. So 3 times 1 minus 2 equals 1. 3 times 1 minus 1 over 2. Let's see, 3 ones 3. 3 minus 2 is 1. Okay, the left hand side is 1. 3 ones 3. 3 minus 1 is 2. 2 divided by 2. Right. Well, 2 times 1 is 2. 2 divided by 2 is 1. Good. So that is so. Remember, you don't need to show that it is true for 2 because all you need is to show that it works from the first start. It works correctly at the start, that is P1. But suppose you were to show that P2 is true, what would you do? Or let me see, let me extend it more. Suppose you wanted to show that P6 is true, what would happen? When r equals 1, you have 3 by 1 minus 2 plus. When r equals 2, you have 3 times 2 minus 2 plus. So let me put r in a different color. This is r1, 2. Then when r equals 3, 3 times 3 minus 2, and so on. Plus, when r equals 4, 3 by 4 minus 2, when r equals 5, plus 3 by 5 minus 2, when r is equal to 6, you would have 3 times 6 minus 2. Notice, it keeps changing. Goes from 1, then 2, then 3, then 4, then 5, then 6. N, no, right here, you adding up from r equal 1 to 6. So n becomes 6. So this becomes 6 times 3 by 6 minus 1 over 2. That's what will happen. So what you would have here then, 3 ones 3. 3 minus 2 is 1 plus. 3 2 6. 6 minus 2 is 4 plus. 3 3 is 9. 9 minus 2 is 7 plus. 3 4 is 12. 12 minus 2 is 10 plus. 3 5 15. 15 minus 2 is 15 minus 2 is what? 13 plus. 3 6 18. 18 minus 2 is 16, and that's supposed to be equal to 3 6 18. 18 minus 1 is 17. 6 times 17 over 2. Let's see if that would work. So let's see now. 10 and 7, that's 17. 17 and 10 is 27 and 3, 30. That's 30 so far. 46, 46, and 4, it's 50 and 1, 51. 51 equals. Alright, let's see what happened here. 2 into 2, 1, 26, 3. 17 by 3 is what? 3, 7, 21. Bring down the 1, carry 2. 3, 1, 3, 4, 5, 51. You see that? And so on and so forth. So R keeps changing. Now, suppose we prove that P6 is true. Then the question is, what about P5, the one before it? And what about P6? I mean P7, the one after it? You haven't proved those. So the thing here now is that you prove that P1 is true. If you prove or show P1 is true, suppose you show that P2 is true. Question is, what about P3? Then if you show that P3 is true, the question is, what about P4, and so on. So what you're going to have to do is to, well, let me rewrite the steps. I erased it. 3 by 1 minus 2 is equal to 1 times 3 by 1 minus 1 over 2. So 3, 1, 3 minus 1 minus 2 is 1 equal 3, 1, 3 minus 2 is 2, 2 over 2. Okay, is 1. Alright, that's part of your working. But the next step now, what should you do? Well, in this case, you assume that pk is true. Notice k is not any specific number, because if you write a specific number, the question will be, what about the number before it? And even if you show the number before it, the question is, what about the number after it? So you write k. You don't specify what k is. Alright? So no one can catch you in their trick questions. Well, it's not really a trick question. Right? Somebody can always ask you, what about the number after? So don't try putting a specific number. So what happens when pk is true? Alright, this is sum from r equal 1 to k. So you have the sum from r equals 1 to k of 3r minus 2. 3r minus 2. Notice r remains as r, because when the first term r is 1, then the second term r is 2, then the third term r is 3, and so on and so forth. So you don't change r. So you see, when you reach the last term, it was originally n, and you write n to n, and you write n here, n here. But now you're going to k. When you go to k and the last term is k, this becomes k, this becomes k, this becomes k. You see that? So it's k, 3k minus 1 over 2. It's k, 3k minus 1 over 2. You see that? Alright. So, there you go. Now the thing is, you are faced with the question, what happened to the number after k? So, what you must do now, show that pk, the number after k is k plus 1. So we'll show that pk plus 1 is true. Alright? Now, what's going to happen is that k becomes k plus 1. So you're going to have the sum from r equals 1 to k plus 1 of 3. Notice r still remains r, 3r minus 2 equals, now the k becomes k plus 1. So what happens? You have k plus 1. So this k becomes k plus 1 now, open bracket, this is the same bracket here, open bracket, 3 times, now this k becomes k plus 1, so you write k plus 1 here, and then the minus 1, close bracket, over 2. See that? Alright, now the next thing, this will always happen in a situation like this. You had r equal 1 to k. R is equal to 1 to k of 3r minus 2. And it looks like this. Alright. Problem is, you have r equal 1 to k plus 1. But notice that if you're adding up from 1 to 2, then 3, then 4, then and so on, then k. Alright? When you reach k, the next term you add is plus k plus 1. This is the next term. But if you add from 1 to k plus 1, it's the same thing as adding from 1 to k. And then adding the k plus 1th term. See that? So, this thing here will become the sum from r equals 1 to k of 3r minus 2. Oh my, what am I doing? Of 3r minus 2, right? Plus what? The k plus 1th term will come here. But the question is, what is the k plus 1th term? Alright, let's see. In the first term, r was 1. In the second term, r was 2. In the third term, r was 3. In the fourth term, r was 4. In the kth term, r was k. So in the k plus 1th term, r is k plus 1. See that? So this is 3 times k plus 1 minus 2. In fact, let me use square bracket here. Let the brackets look different. So since I have round bracket on the inside, I have square brackets on the outside. Alright? Make it look neater. Alright. So what we have here is k plus 1 here, open bracket. We can start simplifying this from now. This is 3k plus multiply 3 by 1, 3 minus 1. Alright? Over 2. Now, we see this thing here. What is it? The sum from r equal 1 to k of 3r minus 2 is this. Is this. The sum from r equal 1 to k of 3r minus 2 is k, 3k minus 1 over 2. So this part here, you write it down here. It happens to be k, 3k minus 1 over 2. Let me look back at it just to make sure. Yeah, k, 3k minus 1 over 2. Is that, you know? See? Plus, and then what we have in brackets here. We can go on multiplying it out and so on while we're working it out. So it's 3k plus 3 1's 3 minus 2 is equal to, alright, so this is k plus 1, this is 3k plus 3 minus 1, 3k, 3 minus 1 is 2, plus 2 over 2, alright. Now, on the left hand side, here we have k, 3k minus 1 over 2 plus, let me write round brackets now, 3k, 3 minus 2 is 1. So it's 3k plus 1. Alright. Now, the thing to do is to show that the left hand side and the right hand side are the same thing. Alright. Now, we could very well multiply out the brackets on the right and multiply out on the left and see what we get, right? But I want to keep it in a more sophisticated manner. From what I'm seeing here, I don't want to change up the right hand side. What I want to do is change up the left hand side to make it look like the right hand side. So let's try and do that. Notice we have this over 1. I could use the LCM method, your fractions. You remember your fractions? Or I could use common denominators, you know. Could use common denominators. Suppose we multiply both top and bottom by 2. 2 times 1 and 2 times this. We wouldn't use this anymore. Now when you have something over 2 plus something else over 2, just add the two things at the top and put it over 2 once. They have k, 3k minus 1 plus 2, 3k plus 1. You remember your fractions, right? When you deal with the fractions, you have to remember that, you know. Alright. Let's deal with the top part. Suppose we multiply it out. We have 3k squared minus k plus 2, 3, 6k plus 2 ones 2 over 2. That's why we can't scroll down anymore. Now we run out of scrolling space. Let's draw a line over here. Alright, let's draw a line here and work on the right hand side of that line. We went down here. Alright. So that is equal to, let me write that this is equal to, what was it again? K plus 1, 3k plus 2 over 2. K plus 1, 3k plus 2 all over 2. This is what you're trying to show. I can't be bothered with writing all of this again. So I'm going to just copy it, combine this into 1, and use it over here. Just drag it. Alright, that saves me some amount of time and energy and scrolling and frustration scrolling back up and down to rewrite everything all over again. Alright, so the left hand side, what is it? Is 3k squared. Negative k plus 6k is what? It's 5k plus 5k plus 2 over 2 equals that. Alright, so we're supposed to be able to factorize this. We use the AC method. We say 3 times 2 is equal to 6. We try to find two numbers that add to give you 5 and multiply to give you 6. 3 and 2. Alright, 3, 2, 6. 3 plus 2 is 5. So we separate the 5k into 3k and 2k. So we have 3k squared plus 3k plus 2k plus 2 over 2 equals the right hand side. And then we factor out the top, 3k, and then inside the bracket is k plus 1. Remember your factorization of quadratic expression. You should remember that, right? Plus 2, and then we have k plus 1 over 2. Alright. So what we have here is 3k plus 2, k plus 1 over 2. What do we have on the right? 3k plus 2, k plus 1 over 2, right? Alright, so on the right hand side, what we have was k plus 1, 3k plus 2 all over 2. So is equal to k plus 1, 3k plus 2 over 2. It's just that the k plus 1 on the left. So we could write it as k plus 1, 3k plus 2 over 2 is equal to k plus 1, 3k plus 2 over 2. So that is proved. Alright. Now, I was saying, suppose you say, boy, all of that work to factorize and so on, and I don't remember how to factorize. Well, you really should remember how to factorize quadratics, right? But suppose you look at it and say, boy, this thing, it looks so daunting and terrible to try and remember the factorization and so on. Alright. If you change up both sides, and simplify them and show, technically it would be correct, but it's not that sophisticated mathematically. Alright? But suppose you do that. Suppose you multiply both sides by 2 to get rid of the fraction. This 2 will cancel itself, so you'd have k, 3k minus 1 equals 2 would multiply this, so it's 2. Oh my, why am I writing equal? It's plus. Plus 2 times, this would be 3k, 3 minus 2 is 1, plus 1 equals, this 2 would cancel when you multiply by 2, right? It would cancel that, so what you would have after this is k plus 1, 3k plus 2. You'd have that, alright? And then if you multiply out the brackets, you'd have 3k squared minus k plus 2 3s 6k plus 2 1s 2 is equal to, multiply out the bracket here will give you 3k squared, 3 times 2 plus 2k, 3 times 1 plus 3k plus 1 times 2 is 2, and then we say this is 3k squared, negative k plus 6k is 5k plus 5k plus 2 equals, and on the right hand side you have 3k squared, 2k plus 3k is 5k plus 2, and then you say 3k squared plus 5k plus 2 equals 3k squared plus 5k plus 2. Alright? That would also prove that both sides are equal. Alright? So that would be the another case. Now notice we had multiplied across by 2. You could also consider this as 2 over 2 and then k, 3k minus 1 over 2 plus 2 times this, 2 3 6k plus 3 minus 1 minus 2 is 1, 2 times 1 is 2 plus 2 over 2, and then just write k, this will be 3k squared plus 2k plus 3k is plus 5k plus 2 1s 2 over 2, and this over 2. So in order to not lose the 2 under, you could do this, and you have 3k squared plus, no, minus k when you multiply 1 by k, right, plus 6k plus 2, but negative k plus 6k is positive 5k. So in the middle here you write plus 5k. So what you would have is 3k squared plus 5k plus 2 over 2 equal 3k squared plus 5k plus 2 over 2, right? So you would have this 3k squared plus 5k plus 2 over 2, alright? So you'd have proved that the left hand and the right hand side are the same. Alright, so that will be it for now. I'll see you in the next video.